Okay.
All right. Welcome to the Blockchain Brief, guys. My name is Erick Pinos, and I'm lead researcher at Game Theory Group and an editor at the Blockchain Brief. Today, I'm joined by two amazing guests. First, Remi, Guy, please introduce yourself.
Hey guys, I'm the research analyst at the Blockchain Brief, and we have a very special guest here, Zhongxing Ming, CEO of Blockcloud. Thank you for taking your time here to have this interview with us. We're very excited to have you here at the Blockchain Brief.
So let's get started. Could you start by introducing yourself and briefly explain your team, your background, and the project that you guys are working on?
Sure. Thank you. Thank you for a quick briefing. And I'm Zhongxing Ming from Blockcloud. I'm a CEO and founder. Basically, we are a group of academic guys who have been doing internet research for about 10 years. I was a PhD in Tsinghua University, and later I went to Princeton University as a visiting scholar. And I started in Princeton University for 1.5 years, and later I became a postdoctor in the Hong Kong Polytechnic University, and now I'm an assistant professor in Tsinghua University. So about 80% of our team members have the same background like me. So they are my schoolmates, roommates, and colleagues during the past 10 years doing internet research. So we have been knowing each other for about 5 to 10 years. And on one hand, we do internet research. On the other hand, we do startups. So that's why we are working together for Blockcloud.
Great. Could you tell us about your project? What problems are you guys seeing in the space, and how are you guys solving these issues?
Sure. Thank you for the question. And we are doing Blockcloud. Blockcloud is a blockchain-based advanced TCP/IP. So TCP/IP is a protocol level or infrastructural technology in the internet. Why we want to do this is because the internet was designed 40 or 50 years ago. At that time, the internet was not so diverse. There were not so many devices. Everything was static, and there was no such kind of serious trust problems in the internet. But now everything has changed. There are so many hundreds of billions of devices in the future. Everything is moving, is dynamic. You have service migration, you have traffic engineering. Everything makes the internet very complicated. So we need to get the legacy technology involved to better support the upper layer application. So that's what we have been doing for the past 10 years to get the TCP/IP layer involved. But so why do we want to use blockchain is that in traditional TCP/IP technology, there was not a comprehensive system to provide the infrastructure with trust and incentive support. So by using blockchain, we can combine the advantages of blockchain supporting of trust and incentive, and we use the future internet technology to better support the upper layer applications. That's what we are doing.
Cool. Now, I think that's a good segue. Could you go into a bit about your tech stack and what kinds of technologies you use? I think in the white paper, we actually saw that you guys you employ directed acyclic graphs. Could you tell us like how that integrates into the greater system that you're building?
Yeah, of course. So can I first introduce the system of Blockcloud, and then I can go deeply to a compacted deck. So Blockcloud is actually a combination of future internet technology and blockchain. So what's the future internet technology in the TCP/IP layer is that 40 years ago, the design purpose of the TCP/IP was to make the United States military posts to survive during the Cold War for the nuclear attack. So at that time, you need a very robust commanding systems, but the telecommunication system was not efficient. So you have IP. Whenever there is a route to the to the opposite end, there is a connection. But now everything has changed. So people now do not care about where and who is providing the service. They care what the service itself is. For example, if you are using a YouTube to see a movie, you really do not care where the movie is or who is providing the movie. You do not care the IP address of the sitting server behind the movie. You just care about whether the movie is smooth, whether it's clear. So why not make the applications directly talk to services rather than IP addresses? Because if you talk to IP addresses, it's indirect and intuitive. So that's why we want to use SCN, service-centric networking. We make applications directly talk to services rather than IP addresses. And if the IP underneath the service changes, it doesn't matter. So the network just manages the IP dynamics itself. For the application layer applications, it doesn't need to care about it, and it provides a significantly better user experience for the upper layer applications, and it also supports better mobility, scalability, and dynamics for the upper layer applications. So that's why we want to use service-centric networking. However, there is two problems that the service-centric networking cannot solve properly. One is trust, another is incentive. So what's the trust problem? Because originally we talk directly to the opposite end, and we know the IP address, and we know who I'm connecting with. So there's no trust problem. But if I do not know who is providing the service and where the service is, how can I trust the service? How can I guarantee that the service is real, not a fake one? So this cannot be fully guaranteed by traditional internet technologies. And we use a blockchain to guarantee that whenever the service is put on a chain, so we have a mechanism, decentralized mechanism to prove that the service is real, not fake. And another aspect is incentive. So for a service provider, currently there are users connect to the provider directly. So if you do not pay me my money, I do not provide you with the service. It's absolutely okay. But if I just publish the service onto the network and I do not know who is using my service and how many people are using my service, how can I guarantee my profit? If my profit cannot be guaranteed, why should I publish service to the internet? So we do need an approach to make sure that the service publisher can get the profit. So that's why we want to use blockchain, because there we can have a decentralized smart contract that makes sure that all the services and users can match with each other, and the service provider can get benefit. That's why we want to use blockchain. So Blockcloud is actually a combination of blockchain technology and service-centric networking. So this is the high-level abstraction of Blockcloud. And for compacted DAG, it's an advanced or it's an improvement of IoT Tango, and it's also a hybrid consensus like Thunder tokens. So for Thunder tokens, it uses a train data structure to select the supernodes for doing the later things. But in our system, we use the compacted DAG. So why we want to use the compacted DAG is because we also have a slow mode and fast mode like the Thunder tokens. But if we want to transfer from the slow mode to the fast mode, a chain structure is very slow. So we need to make it quick, very quick. That's why that's one of the reasons why we use a DAG structure. It's a net of not a chain. So if we transfer from the slow mode to the fast mode, it would be really fast. And we have a mathematical proof in our white paper that the upper bound of the confirmation time can be bounded by compacted DAG. So basically, we have three improvements in compacted DAG than IOTA Tango. One is confirmation time. So in CoDAG, the confirmation time can be bounded, not random. And another is double spamming. So for all kinds of double spamming attacks, we have mathematically proved that it cannot happen unless you have more than 51% of the computational power. And another way is flooding. So in IOTA Tango, it floods to the network all the messages of the ledger. So if there are hundreds of billions of devices in the network, it would be a disaster. So we use a multicast way to distribute the information. So our message loading of the network reduces from ON square to ON. That's a very significant reduce of the network load.
Got it. Just to go back on the incentive. So could you tell us more about the utility of the block token? Maybe tell us more about how verifiers, miners, and service providers can receive block token.
Sure, of course. So that's a very good question. We do believe that a token economy is very important for a blockchain ecosystem. And we believe that there are basically two kinds of token utility scenarios in the crypto world. One is gas burning, like at the rim. So if you want to do anything, you need to burn gas. Another is a deposit way, like EOS or IPFS. So you do not need to burn gas. You just deposit something and you can use some functionalities. And we believe, and we think that deposit miner is more user-friendly and for so maybe IoT devices, because there are so many transactions, but it's very frequent, but sometimes the amount of transaction is very small. So we do not need to burn a lot of gas. So we use a deposit miner. So how do we deposit? Because so on another way, we have a group of miners to challenge the service provider whether the service is real or fake. This is very much like the idea of IPFS. It has a proof of storage, that a number of miners challenging the storage provider. But we extend the idea to a proof of service, that a group of decentralized miners are constantly challenging the service of the service providers to see whether it's real or fake. So what if the service is fake? What happens if the service is fake? We need the service providers to deposit Blockcloud tokens before they can publish the service and receive tokens from the network. For example, if the service is the value of the service is 1,000 block tokens, then the service provider must first deposit 1,000 block tokens before it can publish the service to the network and receive tokens. If the service is fake, the service provider is punished and the tokens will be given to miners.
All right, awesome. Yeah, thanks. That really clarifies the token utility, which is an often question in this space. We were going to ask about competitors, but you already covered that splendidly earlier. So I think to close off, is there anything you want the audience to know or any other updates you want to share about your progress thus far?
Sure, of course. So you just said about competitors, but we do not really think that we are competitors of IOTA or we are competitors with token Thunder token, because we are at different layers. So we are at the underneath layer of the internet infrastructure to supporting the upper layer applications. That is, we are like a infrastructure. So anything can run over Blockcloud, including IoT and standard tokens. So we are at the lower level. So, and another very important thing is that we do have a loose coupled layered structure. And for the 4-layered structure, we do not need particular technology to implement our ideas. So currently, we think CoDAG is a very good way to do the ledger thing. So we use CoDAG. But if in the future, there's more advanced technology, we can also use that technology. It doesn't matter. So we just, at the first layer of our Blockcloud, we just need a very good ledger. So what kind of ledger it is, it doesn't really matter. So that's the basic design principle of the internet. So loose coupled layered structure, and each layer can evolve independently. So that gives a long-term survival possibility of the system. So we believe that the blockchain is technology at its very early stage, and you cannot say that there is a technology can survive for the coming 10 years. So we do need to provide the possibility of evolution to the system. So whenever there is a better technology, we can use it and make the system better. That's a very important design idea of Blockcloud. Okay.
Yeah. Thank you for your time. We're very excited about your project, and I agree. I think as we get new devices, new technology needs to evolve. The old IP TCP needs to evolve as well. And I believe your testnet is coming out in Q4 of 2018, right?
Yeah.
Yeah. We're very excited about your project. And audience, if you have any questions, leave comments below. And this was Eric and Remi from the Blockchain Brief. And we're excited to see you guys next time.
See ya.